Good afternoon, everyone, and welcome to this afternoon's webinar, Revit MEP Ducting Soup to Nuts. My name is John Atkinson. I'm an MEP application engineer here at CTC. And today we're going to be talking about, ductwork. So one of the things about setting up our ductwork is that we want to start off and make sure all of our settings are set up correctly first. So what we want to do is we want to get into our mechanical settings, and there are a couple ways we can do that. On our Systems tab, we can select the little down arrow on either of these panels for HVAC, mechanical, or plumbing and piping. And that's going to bring up our mechanical settings. And here we can go through and define how the visibility graphics are going to be controlled, what are the line styles as the ductwork goes above or below another piece of ductwork, how large the gap is between those dashed lines or between the ductwork. And then typical duct settings. Are we going to use annotation scale for the lines and fittings? And all of this, what is our air density, dynamic viscosity? And then are we going to be using a separator for our tags in our rectangular duct size or duct diameter? And then we can also use set our angles for our fittings. We can use any angle, or we can start setting an angle increment. We can set this to 15 degrees or whatever, or we can use very specific angles, 11 1/4 all the way up through 90 degrees, and we can turn some of these on or off. The next one down is conversion, and we can set this by the system classification: supply air, return air, exhaust air. And for each of these we can set what is the main typical duct type that's going to default. Conversion is used mainly for setting up our generate layout, and we'll get into that in a little bit. So if we come into supply air duct type, maybe I want my main to default to rectangular taps with 1.5 radius elbows, and I'll default the offset from our level to 10 feet. For my branch duct types, I'm going to use round with taps and 1.5 diameter elbows. Offset, again, I kind of want to keep these the same. And we can also define flex duct type if we want to have our generate layout automatically put that flex duct in for us. And then we can define a maximum length of that flex duct. As we go into our duct settings for rectangular, oval, and round, we've got all of the sizes listed for each of those. And then these two columns we have used in size lists. So as we're drawing our ductwork and we want to change the size, we can go all the way down to 3 inches or even 3.5. If we don't want to see those in our selections, we can turn these off and just start at 4 inches. We can also, over on this side, use in sizing, as we're going through Revit and we've modeled up an entire system, we can use the duct sizing tool, and it's going to come in and use this column to define its sizes. Up on the top, we can hit new size, and we can add a new size, and whether or not that's going to be included in the size lists and used in our duct sizing later on. And we can also delete any sizes that we're probably never going to use. Calculation. This is the list of calculations that Revit will use when running duct sizing, and we have a couple of options here. We've got Holland, forgive me if I'm saying that wrong, Colebrook, and I'm not even going to attempt the other one. And if you're curious as to how that's being calculated, we can look through the entire calculation and see how it's working out. And what's being used for round, rectangular, or oval. Then further down we have some definitions as to which each of those characters in the calculation are based on. The bold is for parameters that are associated with the ductwork. So if we have loss coefficient, that's going to be supplied by the ductwork itself. Once we have those settings, we can start setting up for our project systems. We can come down to our duct systems. I'm just going to select our supply air and open up the type properties. And from here we can either duplicate or select a different one and adjust its settings. And then we have graphic overrides for each of these systems that we can define the color, and if we want to change the line pattern, or if we want to override the line weight, we can do that right here. So this is basically saying all of my supply air as I draw my ductwork in my plan view is going to be green. If we look at return air, we've got red. Material, we can define special materials for certain types of ductwork. If you had duct socks or something, you could go in and redefine that material to be some sort of a fabric, and open up the material editor and go through here and find, say either a metallic or a fabric, and set that for your materials. And this will affect the appearance and the rendering appearance for any 3D views that we want to set. Under calculations, we have a few choices for flow only, none, or performance. I typically leave this to all. And then the system classification is defaulted to return air. If we want outside air, we've given it a system classification of supply air. And a little further down, we can set the abbreviation, and this is what's going to be populated in our tags. We can also define our rise and drop symbols. For outside air, we're using a cross. If we go to return air, it'll give us a single slash. And if you want to know exactly what that's going to look like, we can select those the little button with 3 little dots on it, and change it to whatever we want, whatever our office standard is for that particular type. If we go down to our duct families, we can do the same thing. We can set all of our types based upon what routing preferences we want. And if I just go to the 1.5 width, this is where we would define the roughness, which is going to be used in our friction calculations, and we can define our routing preferences based upon what type of elbow are we going to be using for this. If we need to define a different type of elbow for a new type of family. We can also define whether it's going to be prefer a tap or a T, and this is going to give us our default connection when running into another piece of ductwork. Typically, we want to keep all of these junctions, crosses, and whatnot to a single type. You'll see that this junction has a tap and a T. The T is grayed out, but if I were to hit the drop down and change to a T, now my tap is grayed out. So when setting up your routing preferences for your ductwork, it's best to just not hit this plus sign, mainly because it's just not going to be used. But we can come down and select our cross. What's going to happen if we have basically a four-way cross? What type of transitions are we going to be using from one size to the other? Are we going to be using 45 degrees, 60 degrees, 15 degrees? And then the multi-shape transition, when we're going from rectangular to round or rectangular to oval. And then you'll see the transition oval to round, we're using rectangular, so it's set to none. And also if we're using any type of unions between two rectangular pieces that are coming together, say one is existing, or you need to split a system, it'll throw in a union. And then caps, what cap is going to be used at the end of any of your ductwork, and we'll just set that to rectangular and cap standard. If you don't happen to have any families loaded for a particular type of fitting, we can go into load families and pick a new fitting to replace something that's that you are not going to be using. So once we've gone through and defined all of our parameters for routing preferences, graphic overrides, and additional information for our systems, we can start by adding in our air terminals. So here I've just placed 4 air terminals. I placed them at 8 feet above level 1, and then I placed a VAV box and I've set that at 10 feet. There's a couple ways that we can run our ductwork. We can come in and manually create duct, pick our connection, set our height, and start drawing, and it'll all connect and choose the appropriate color for that system type. Or we can highlight an entire system hit our duct button, select the type of system. This is going to be supply air. Change our system name, and we generally want to keep this the same as whatever is supplying it. So in this particular one, I'm going to call it VAV 1-1. And before we leave this command or deselect anything, we have some options along the top where we can select our equipment supplying the system, and you'll see we get a bounding box that goes around all of the elements. We can use generate layout, and you'll see we have some solution types. Is it going to be a network, a perimeter, or is it intersections? And then each of those is going to have a series of possible solutions, and we can just click through them to find one that matches what we want more or less. If I go to perimeter, we want to go through and probably find one that is really going to meet our needs in the most efficient manner. Now, one thing you'll notice is that as I'm going through these solutions, I have a blue line or series of blue lines, and that's going to represent our main, which we defined earlier is going to be rectangular and default to 10 feet. We also have green, which is going to signify anything that's going to get a branch connection. And then we get yellow. We don't always get yellow, but we'll occasionally get yellow, and what that means is there's a possibility that this won't connect properly. I'm just going to go back to my first network one, and I'm going to take a look at this settings button, and you'll see that my main is looking at that rectangular taps 1.5 width elbows. My offset is 10, and we can change this, override the default settings from our mechanical settings right here. If I go to branch, you'll see that it is indeed using round ducts, 1.5 diameter, offset 10 feet. But what if I don't like any of the solutions that Revit is trying to provide me? I can come up to Edit Solution and pick some of the ductwork that maybe I want to move. Maybe I want to put in a jog. And I can select and move just the ends. Oop, I'm going to cancel that one. Let's go back in, and if you ever need to, you can select just one of the air terminals and select our generate layout. And I'm okay with this solution. This seems to work pretty good. I don't have any yellows. Everything seems to be about right. I'll hit Finish Layout, and it'll automatically put in the ductwork for me. If I select it, you'll see that it is indeed at 10 feet high. This one is round. This one is rectangular. And I can take a look at the flow going through each of my pieces of ductwork, and you can see I have zero flow because all of my air terminals are set to 0. So if I'm working through either a schedule or something that tells me what the CFM values for a particular space are, I can come in, define those either before or even after we've set our ductwork, and I can change them. On here. There. And once I've set these new values, I can come in and just hover over one piece of ductwork, hit tab until I get the entire system, and then come up and select the duct and pipe sizing tool. And here I have a couple of options. I can change the sizing method to friction, velocity, equal friction, or static regain. I'm okay with just using velocity, and I can use velocity only, or I can use the and or buttons to come up with friction. So perhaps I wanted to change that to 1200 and 0.1. Down here under constraints, I have branch sizing, which is going to be used on pretty much everything we've just selected. And it'll either use the calculated size only, or I can match the connector size on my equipment or air terminals, or the larger of the connector or the calculated value. I also have the option to restrict the height. So if I know I have a tight plenum space and I can only be 12 inches or 16 inches, I can lock that height and it will automatically increase the width of my rectangular ductwork. We can do the same thing with our width. If you're going down a corridor, you have more plenum, but you're concerned about the width, you can restrict that width as well. We say OK. If we take a look at this, 12 by 12, I have 800 CFM flowing through. If I were to go in to my duct sizing tool, and let's restrict that height to 8. Now you'll see my ductwork is 18 by 8, 18 by 8. And as you look at this ductwork, you'll notice the top elevation is set at 10'4", the bottom elevation is 9'8", and our center line is at 10 feet. We can edit the justification as we're creating or editing ductwork to be top left, top center, top right. So if we're trying to stay tight against some bar joists coming across, then we can tell it that our justification is going to be at the top. So everything that we draw is going to be defined by that justification. So with after the Generate Layout tab, let's say you need to add another air terminal. Just going to copy one over here. We have a couple of choices. This is not assigned to a system, but we could certainly come in here, select it, our duct system, edit system, and say add to system. But Revit is smart enough to know that I can actually take this piece of, our air terminal, and I can select the unit, draw from, set my height of my connecting ductwork, which will be round, and just tap into the duct there. I can also use some of our modify commands trim and extend to single element, select my ductwork, and go that way. Another option I have is select my air terminal, connect into, missed it, connect into my ductwork, and it'll automatically put that in. Now, if you take a look at this, this is going to be rectangular. What it's doing is it's trying to match the same type that I'm trying to connect into. So if I undo this and use connect into on this round piece of ductwork, now it's going to be round. Some other things about ductwork that you can use. If you had a couple of pieces that need to be connected, instead of dragging around or drawing to and from, we can just use trim and it automatically adds those fittings in. This works if the elements are on two different planes, and it'll automatically put in the appropriate rise and drops. I'm just going to move this down. I'll just put it at 6 feet as an example. So if we say draw, it'll actually put in an elbow and an elbow and a piece of ductwork to connect those. And that's all I have for today. So, thank you for attending. And if you have any questions, don't hesitate to either give us a call, or if over the next couple minutes, place them up. And I just got a question, how to get the video. We are recording this and it will be up on our YouTube channel in the next day or so. So subscribe to our YouTube channel at CAD Technology Center, and you'll see our previous webinars for piping, soup to nuts, as well as the this one. And if there are no other questions, thank you and have a good afternoon.